Assalamualaikum. Good day for everyone. So today's lecture for this week we try to do ritual. As you can see, for this week we try to do the lecture number 9, which is digital train modeling. So again, the information about the technical talk on Wednesday and mini project. How is the progress? Make sure that the progress will be smooth. And written test also we have done, and for the practical test, so be aware that might be around week 10 you need to prepare. And this is again the assessment for ECG 579. Try to look again if your written test might be, you feel that it's not very good, try to make very comprehensive in practical tests, and finally for the final examination. So only for group 7 C3 on Monday from 4 to 6. So as what we planned for this week is week number 10, 7th May 2018, and the lecture will be lecture 9, and so on for the following weeks. And also for group 7C6 Tuesday 11 to 1 p.m. start from this week 8 May, lecture number 9. Group 7C8 start from 8 to 10 a.m. For lecture number 9 also. So try to look the learning outcome. So if you look for the learning outcome for this lecture, this will be cover for digital representation of three-dimensional surface, DTM interpretation, which includes slope models, hydrological models, and also intervisibility. And last but not least is about the DTM visualization. So for this slide and the following slide, try to read and try to look the differences between DTM and also DEM. So if you can look very thoroughly about the DTM versus DEM, from the figure you can find that the DEM, it will be include also the surface and together with the object. But if you look for DTM, which is the digital train model, is only cover for the surface of the earth. I start from the surface of the earth. So if you look the nature of DTM, actually you can look the DTM is a simplest digital representation of portion of the earth's surface. This has been mentioned from the previous slide. It will cover only the surface of the earth. And this is the figure where it start with the surface of the earth, from the reality until at the end that we can do for at least for the terrain analysis due to the terrain surface of the earth itself. And in DTM interpretation, some of the object maybe cannot be seen. So what that we should do is we can manipulate. For example, like I mentioned to you all from the previous lecture, maybe some of the object might be hidden by cloud. So what that we can make some assumption of the object, maybe we can make some manipulation. So this is what happened in DTM interpretation, one of it, together with the slope models. So when we try to look in terms of the slope models in the digital train modeling, so it should be has a direction and also length. This is what you can see figure. Where is exactly the figure of the slope, and together with the the object of the aspect. Actually, the aspect is horizontally between x and y, and when you look for the slope, is between z and x or z with y. Okay, so this also the formula that will be used in GIS, especially GIS software, how that they want to create the surface of the earth by using these equations, and also the expression of slope, where this actually is come from the mathematical concept. And together with the calculation of the slope, that this have been implemented in the GIS software. Together, after we have made some derivation in the GIS software, have been done by programmer due to the equation previous slides. So you can see from left original, it can go more detail or more accurately on the right. In terms of aspect, the direction of the normal vector in the degree clockwise from north. So normally the category of aspect, it will cover from the north to northeast, east to southeast, and so on, as you can see from this slide. And how they want to make a calculation of aspect due to this formula, 180 minus arctan and so on. So this actually equation can be made by programmer so that it can be included into the ARCS software. So later on, if you put, for example, the coordinate of xy, then it can identify the aspect of this surface of the earth. So this aspect map should be look like, okay. And the curvature also. So when you talk about a curvature, it describes the nature of mass movement on a slope. Okay, commonly it includes three types: mean curvature, contour plane curvature, and profile curvature. This is what that you can see from the figure, where exactly the location of those three curvature. And this is the calculation of the curvature. Maybe you, for your level, no need uh, to identify it. So just to understand that this equation actually will be used in the GIS software that have been programmed by programmer. So the use of curvature is very important, that it can make the differences between the convergence and also the divergence, together with the acceleration and also deceleration. So acceleration actually is the very high gradient, and acceleration is very not very high. So this is what happened due to the contour curvature lookalikes and also the profile curvature, based on the previous slide. Okay, then we go to the hydrological models. So when we talk about hydrological models, it's something more related with the hydrology, water. And so this is more study on how the drainage, for example, the water resources, and if you look for the drainage network delineation, they should have a flow direction. So you understand that the water should flow so that it can go smoothly without maybe we need to uh, avoid the flood and also the others problem. So this is how that they can make some assumption based on the 8 possible direction for the flood. You can see in this figure. So mostly the GIS expertise the GIS expert try to look into this direction so that the water can go smoothly, so that the flood can be avoided. Together with watershed also, what is defined as a tribute. So this watershed, what we call as a polygon, made from polygon in GIS. Then it should also have a direction so that it also can avoid the any water increases happen. So this is what you can see in the map of watershed. It's come from the original and then you can derive through the watershed map. And so on, we go to the drainage network. The drainage network also important as before. Mostly we want to look in terms of the flow direction. So this is the connection, the flow, how that the flow of direction could be. And this is last that you can see the map of the drainage network. Because okay, based on the threshold also is very important because when you look, the more threshold will be, so it will be very little flow if compared with the small threshold. Okay, we go to the next one, which is intervisibility. So for the intervisibility, actually is viewer points. So how far that the viewer, for example, like a surveyor, when they want to make a surveying of the surface of the earth, so how far that they can look this figure. So you can see from the viewer position, so that they can get the location coordinates and etc. So after of all, when they make for the viewer, like I mentioned from the previous slide, then you can make some intervisibility analysis due to the each layer. Then go to the detail and visualization, where it covers with the contouring, relief shading, combination of 2D data and perspective display. So like I mentioned from previous lecture, yes, contouring is something related, contour lines, something related with the surface of the earth. So they might be need to look in terms of x, y, z, especially z coordinates, so that they can contribute, as you can see from this slide. Together with the binary is something related where they make some background image inside. Relief shading is what we call as a Lambert-Wilson law, and they have stated brightness of any small area. They should have a calculation how that they make a affect intensity of reflected sunlight. So you can see very accurately how that the deep of the shape of the earth can be. Combination with 2D data also can make like a contour display, as you can see this figure. This is what we call as a combination of 2D, and we also have okay, for the perspective views. Normally is try to simulate the observation in real world vision. So mostly it might be combination of 2D and 3D. So as you can see, this figure shows how it looks like. And later on you can look the small location, and you can make maybe 360 degrees how it will look like. Draping with vectors and area photograph, the combination of the area photograph, so it will be very good conditions together with the object like buildings, river. So it also can be draping with object, a real object that can be found from Google's Earth. And sometimes also we can make some animation or virtual reality. And some of it maybe we use VR. So hopefully that this lecture, you can look in terms of the summarization of this lecture. Try to look again the learning outcome so that you can figure out what kind of summary of the lecture it will be. So at the end, thank you very much for listening, and also hopefully you can understand more after this. Thank you very much.